Hi everybody. We're teaching a statics course. We're continuing our discussion of vectors. When we multiply two vectors by the cross product, the result is a vector quantity. When we multiply p by q, the resulting vector is perpendicular to both p and q. Its direction is found using the right-hand rule. We hold the four fingers of our right hand in the direction of the first vector, p. We rotate our palm toward the second vector. When we close our palm, our thumb points in the direction of the vector r, which is the cross product of p and q. The result of the cross product is a vector quantity. The magnitude of this vector quantity is equal to p times q times the sine theta. It is equal to the product of the magnitudes of p and q and the sine of the angle between them. The cross product is not commutative because if we interchange p and q, the resulting vector changes direction. P times q is not equal to q times p. Their magnitudes are equal, but their directions are opposite. The cross product only has the distributive property, so we can open the parentheses. When multiplying the sum of q and r by p, we can write it as the cross product of p and q plus the cross product of p and r. Let's also find the cross product in terms of rectangular components. Let's see how. First, we can write it in terms of ijk and distribute the parentheses. This is an alternative. When distributing the parentheses, just like with dot product, we can distribute the parentheses so that we obtain 9 terms. Of course, here we encounter multiplications of unit vectors again. So, let's see how to do them. For example, what is the cross product of I and I? What is it equal to? Let's see. The cross product of I and I is still a vector. But what is its magnitude? Since the angle between them is 0, sine 0 is equal to 0. And the result is 0. The resulting result is the 0 vector. For another example, let's do the cross product of I and j. When we multiply I and j by cross product, the magnitude of the resulting vector is equal to 1. Because the angle between them is 90 degrees, sine 90 degrees equals 1. Their respective magnitudes are also 1. Therefore, 1 times 1 times 1 equals 1. So, the cross product of I and j is a unit vector. What is its direction? We find its direction again using the right-hand rule. When we multiply I and j by cross product, we hold the four fingers of our right hand in the I direction. We rotate our palm toward j. When we close our palm, our thumb points in the direction of k. Therefore, the cross product of I and j is equal to k. We show what these 9 alternatives are equal to in the figure. We can find it using the right-hand rule, as well as easily using the circle on the right. For example, let's find from the circle that the cross product of I and j is equal to k. We draw this circle. We place ijk counterclockwise. When we rotate counterclockwise, we rotate in the positive direction. Let's multiply I by j by cross product. Which direction are we going when we take the shortcut from I to j? We're going in the positive direction. Therefore, the result is positive k. If we multiply j by I, this time we're going in the negative direction. We're going from j to I negatively. The result is minus k. We can do other alternatives like this and find the result. We can find the cross product by distributing the parentheses or by expanding the determinant. We can do this. We write ijk, the unit vectors, in the first row. We write the rectangular components of the leading vector p in the second row and the rectangular components of the second vector q in the last row. By expanding this determinant, we find the result of the cross product. There are different ways to expand the determinant. I find this method to be a practical one, and I recommend it to you. What are we doing here? We write the first 2 columns on the right side of the determinant. Then, we multiply the terms on the diagonals shown in the figure. We add the ones below and subtract the ones above. If the angle between two vectors is 0, if the angle between them is 0 or 180 degrees, since sine 0 or sine 180 degree equals 0, the cross product of these two vectors is equal to 0. P times Q is 0. The opposite is also true. If we find the result 0 when we perform the cross product of P and Q, it means these two vectors are parallel to each other. They can be in the same direction or in opposite directions. To determine whether two vectors are parallel, in the same direction, or in opposite directions, we can perform cross product. There is no division operation with vectors. We can perform mixed product. If we multiply three vectors by a mixed product, the result is a scalar quantity. We can multiply the vectors p, q, and r by a mixed product. In mixed product, there is a cross product and a dot product. Here, when we multiply p by q by the cross product, we obtain a vector. We then multiply r by that vector using the dot product. We can't perform the dot product first, because when we multiply q by r by the dot product, the result is a scalar. If we multiply q by r by the dot product, we can't multiply p by the resulting scalar by the cross product. Therefore, there's no need for parentheses here. We can find the mixed product using the determinant. When performing the mixed product, we create and expand this determinant by writing the rectangular components of the first vector in the first row, the rectangular components of the second in the second row, and the rectangular components of the third in the third row, without changing the order of the vectors. The result of this determinant is a scalar quantity. Now, let's consider the mixed product of p, q, and r again. When we multiply p by q by the cross product, we obtain a vector from there. Dot product is commutative. Therefore, we can move this to the right side of r. We can do this by taking advantage of the property of dot product. The result remains the same. If we write these as determinants, p, q, and r on the left side are written as p in the first row, q in the second row, and r in the third row. The one on the right side is written as r in the first row, p in the second row, and q in the third row. What's the difference when comparing them? The bottom row has moved to the top. This means the rows have been swapped twice. If two rows are swapped in a determinant, the sign changes. But if they are swapped twice, the sign reverts to its original form. That's what's happening here. It seems the determinant on the right and the determinant on the left are the same. We get the same result. There's another property of mixed product. The place of the cross product and the dot product can be swapped. The result remains the same. After all, we're doing mixed product with the determinant. In the determinant, if the order of the rows of p, q, and r is not changed, the result remains the same. Goodbye.